Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Troubleshooting in IT is a logical, step-by-step process used to identify and resolve technical issues effectively. It's more than just trial and error. It's a methodical approach designed to eliminate uncertainty and find the true cause of a problem. In the CompTIA Tech Plus exam FC0-U71, troubleshooting is highlighted as a foundational skill in Domain 1 because it applies across hardware, software, networking, and security contexts. Once learned, this methodology becomes second nature and works consistently across devices, systems, and IT roles, no matter the environment. A structured troubleshooting process matters because it prevents guesswork and reduces wasted time. Instead of jumping from one random fix to another, you work through a logical sequence that ensures no detail is overlooked. This approach also improves team communication because everyone can see where you are in the process, and it supports quality documentation that can help with future incidents. The Tech Plus model includes 6 clear steps that you'll return to repeatedly throughout your IT career, whether in a help desk, system administration, or security role. The first step is to identify the problem. You begin by gathering information directly from users and by observing how the system behaves. Ask targeted questions. What changed, when the problem started, and what exactly the symptoms are. Reproducing the issue when possible helps confirm its scope and consistency. During this stage, document any initial symptoms, error codes, or patterns so you have a record to work from in later steps. Step 2 is to establish a theory of probable cause. Using the information you've gathered, develop one or more possible explanations for the problem. Consider recent changes to hardware, software, or settings, as well as potential user actions. Reference vendor documentation, online resources, or internal knowledge bases to strengthen your theory. Keep your ideas realistic. Focus on what is most likely, rather than jumping to extreme or unlikely causes first. Once you have a theory, step 3 is to test it. This is where you apply safe, controlled changes or run specific tests to confirm or disprove your assumption. You might swap components, connect a known good device, or adjust a setting to see if the problem changes. Avoid making irreversible changes before confirming the cause, and be prepared to loop back to step 2 to form a new theory if the current one fails. Safe testing is essential because careless changes can make the problem worse or cause data loss. Always back up configurations, settings, or user data before testing a fix. If possible, use a test environment or non-production system so you can experiment without risking business operations. Controlled testing not only reduces risk, but also builds your confidence as a technician. Step 4 is to create a plan of action. Once the cause is confirmed, design a step-by-step solution that addresses the problem without introducing new ones. Include a rollback plan in case the fix causes unexpected results, and communicate with users if the changes might disrupt their work. Whether the solution involves a patch, a configuration change, or a hardware replacement, the plan should be tested in principle before it's applied. Step 5 is to implement the solution. Carry out the fix according to your plan, paying attention to timing, dependencies, and potential system impact. Follow each step carefully and monitor the system during and after the change to ensure stability. Keep communication open with users or stakeholders so they know what's happening. If unexpected behavior occurs, pause the process and reassess before continuing. Step 6 is to verify full system functionality. This means testing not only that the original issue is gone, but also that no new issues have appeared. Confirm that all affected features work normally and that related systems or processes are functioning as expected. Verification builds user trust and ensures that the problem is truly resolved, not just temporarily hidden. After verification, consider preventative measures. These could include applying software updates, training users, or setting up system monitoring to detect similar problems early. Looking for root causes rather than just treating symptoms helps reduce the likelihood of recurrence and improves the reliability of the system over time. The final step in any troubleshooting process is to document your findings. Record what the problem was, what caused it, how you fixed it, and what the results were. Good documentation helps your team resolve similar issues faster in the future, supports process improvement, and can be essential for audits or compliance. Treat documentation as a professional responsibility. It's part of closing out the work properly. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Real-world examples make the structured troubleshooting process easier to visualize. If a user reports slow Wi-Fi, you start by identifying symptoms, testing basic connectivity, and isolating whether the issue is specific to their device or affects the network as a whole before verifying performance improvements. For a printer that won't respond, you'd check power and cables, confirm the printer is online, review driver updates, and clear the print queue. A failed software install could involve checking system compatibility, verifying user permissions, ensuring sufficient disk space, and interpreting any error codes. Regardless of the scenario, the steps identify, theorize, test, plan, implement, verify, and document remain consistent. The methodology applies across every domain in IT. Infrastructure problems, like a failing hard drive or faulty cable, are handled using the same process as software errors, such as application crashes or update failures. Even security-related issues, like repeated login errors or suspected malware, follow the structured flow, although those cases require added caution. This isn't just a help desk skill. It's a universal approach that can be applied to any technical problem, from networking to cloud services. Customer service plays a big role in effective troubleshooting. Keeping users informed throughout the process builds trust and sets realistic expectations. Use plain language, especially when working with non-technical users, and avoid unnecessary jargon. Show empathy by acknowledging the impact the problem has on their work. Clear, respectful communication can make the difference between a frustrating experience and a positive one, even if the resolution takes time. The right tools can make troubleshooting faster and more accurate. Software tools might include event viewers, log analyzers, system monitors, and command line utilities. Hardware tools can range from cable testers and multimeters to swapping in known good components. Documentation tools, like ticketing systems, knowledge bases, and internal wikis, capture what's been tried and what has worked in the past. Knowing which tools to use and when ensures you approach each step efficiently. Checklists and scripts are common in professional environments for issues that occur frequently. A checklist ensures no step is skipped, even when you're in a rush. Scripts provide structured, repeatable processes for common problems like password resets or printer errors. However, they should be seen as guides, not rigid instructions. Critical thinking is still required to adapt to unique situations. Developing your troubleshooting skill set takes practice and review. Over time, you'll recognize patterns more quickly and anticipate common causes. Reviewing past tickets or documented case studies helps you refine your diagnostic instincts. As you gain experience, you'll learn to prioritize fixes that have the highest impact before investing time in deeper, less likely causes. It's also important to recognize when an issue should be escalated. Some problems will be outside your current scope, authority, or expertise. Escalating to a higher-tier technician, vendor, or security team ensures the problem gets resolved more quickly and avoids wasted effort. When you escalate, include all relevant documentation and steps you've already taken so the next person can pick up without repeating work. In team environments, troubleshooting often involves collaboration between specialists in networking, hardware, software, and security. Share your observations, evidence, and working theories clearly. Keep the focus on resolving the issue rather than assigning blame. Effective communication and documentation within the team improve efficiency and prevent misunderstandings. There are common pitfalls to avoid. Skipping steps or jumping to conclusions can lead to wasted time or even new problems. Ignoring user input can cause you to miss valuable clues about the root cause. Making changes without backups or rollback plans risks data loss or service interruptions. Failing to verify the fix or to document the resolution leaves the process incomplete and less useful for future reference. For the Tech Plus exam, troubleshooting scenarios may require you to choose the correct next step or identify which step was skipped. Practicing the 6-step model in real life or simulated situations builds confidence and accuracy. Understanding the order and purpose of each step ensures you can adapt quickly to any situation the exam presents. Troubleshooting also integrates with other domains. In infrastructure, you may use the method to diagnose failing devices. In applications, you may apply it to fix software configuration errors. In security, you might troubleshoot access problems or contain and remediate a threat. Because it connects concepts like input/output, processing, storage, and networking, the structured method is a cross-domain skill that will evolve with your role. To summarize, the 6 steps are: identify the problem, establish a theory of probable cause, test the theory, create a plan and implement the solution, verify full system functionality, and document findings, actions, and outcomes. Following this order consistently will make you both a more efficient troubleshooter and a more reliable IT professional. In the next episode, we will begin our coverage of Domain 2, Infrastructure. We'll start with an overview of its scope and importance, exploring how it connects devices, components, storage, and networking into a functional system. Understanding infrastructure is key to both exam success and professional competency, as it forms the backbone of nearly every IT environment. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.